Simplified expression to represent area. Question 3. Write a simplified algebraic expression to represent the area of the figure. So we are interested in inside area of this figure. So let me just shade it a bit, right? So that it's clear what we're trying to figure out. Okay, so that's what. Okay, that's good enough, correct? So we want the area of the shaded portion, inside area, right? Now this question is kind of interesting. Some of the dimensions are not given to you, right? So you have to figure them out. So for example, I didn't mention what this height is here, right? Now we know this total height is x and this is 4. And therefore, how much is this? That should be x minus 4. Is it okay? So if they are not given, you can always figure out, correct? This is very important. Similarly, I have not given how much is this from here to here, correct? Now, this big length is 22x plus 4 and this one is 2x minus 1. So how much is this? That is difference of these two. So to find this length, we can do 2x plus 4 minus of 2x minus 1. So if we minus them, so we get here 5. Do you see that? And so this length here is 5 from here to here. Correct? Now you can check it. How can you check it? 2x minus 1 plus 5 is 2x plus 4. Does it make sense to you? Similarly, x minus 4 plus 4 is x for you. So you can check. So it's good to write the dimensions and then check them also. That's kind of very important. Now, we need to figure out how to find area of this shaded portion. There are a couple of ways to do it. One way is that what we can do is we can think that we have a big rectangle here, out of which small portion has been taken away. So that is a good approach, neat and clean, right? So we have area of shaded portion. We can write area of shaded portion is equals to S for shaded portion. So area of big rectangle minus area of small rectangle. Let's call this small rectangle, okay, SM, small, right? Small rectangle. So that is one way of doing it, correct? Let's do it like this first. So area of big rectangle is length into width, right? So that means we can say 2x plus 4 times x. So that is area of big minus area of small. Small is 5 times x minus 4, correct? So that length is 5 and width is x minus 4. So minus 5 times x minus 4. Correct? So that becomes the area, correct? Let me just separate this so that we don't have any confusion here. So we can always expand and simplify this expression, right? So if we do that, we get what? 2x squared plus 4x. You have to multiply this with both, right? That's a distributive property, correct? And similarly here, we'll do with 5, this and this. So we get minus 5x and minus makes it plus 20. Do you see that? That. And then we can combine the like terms and we get 2x squared and plus and minus will give me minus x plus 20. So that is the simplified expression for this area, right? So that is what we get. So that's it. So that is how we can do it, right? So here main thing which you have to learn is that if all the dimensions are not given, how to find them, correct? And then use them. Now the other way to find the area could have been that you could have seen this triangle like this, rectangle like this. So you could think one this rectangle and the other this rectangle. Do you see that? So we can do like that also. That is an alternate way to do it, correct? So let's try to do that also. So here this area is 2x minus 1 times x, right? So we have area equals to area of big triangle plus, I should say, rectangle. So area of big rectangle plus small rectangle. So this one is x times 2x minus 1 plus small one 4 times 5. 4 times 5, correct? So if you expand this, you get what? 2x square minus x plus 20. Do you see that? So you get the same area. So either way you could do your equation, right? But more important is to figure out these dimensions. Then only you can do it. And you get the same expression, correct? So that is how you find area for a figure like this. Okay? Thank you.